All right, class, welcome to section 2.6, solving absolute value equations and inequalities. So we are done with the linear functions, and, and then, of course, if you've noticed, we took it nice and slow with solving linear equations, looking at linear equations in two variables, and then moving on to the functions. Same thing, we are going to start with linear equations and linear inequalities, not linear, absolute value equations and absolute value inequalities in one variable. Remind ourselves how these work so that in the next section we can move on to the next type of function, which is the absolute value function. Now, of course, an absolute value function is very much the same as a linear function because we simply are given two broken lines. So an absolute value, as you see, is really a piecewise defined function that is the same thing as x. So the line of x, if you're talking about positive x's, and it's negative x, so it's a decreasing, falling line, x, if x's are negative, because the absolute value of a number is simply the distance from that number down to 0 on the number line. So here it is, the number line. What does it mean to find the absolute value of some kind of number x? It simply means, let's say I'm picking the number 3. Say I'm picking the number 3. What is the absolute value of 3? Well, 3 is 3 units away from 0. So that's the distance that I have to travel to get from 3 down to 0. Well, what about negative 3? Well, the absolute value of negative 3 is how many units do you have to travel to get from negative 3 up to 0? That's 3 units. So it doesn't matter what side of 0 you're at. The absolute value of a positive number is itself the absolute value of a negative number less than 0. You have to take its opposite. In other words, you have to make it positive again. So as you see from the graph that you by now should know of the absolute value function, all the y values are always positive, right? So the answer are always positive. We say non-negative as in 0 can be included as well. So 0 is neither positive nor negative. So you just exclude negative values, but of course the absolute value of 0 is 0 because you don't have to travel anywhere to get from 0 to 0. So if we solve an absolute value equation, let's say here is a very simple absolute value equation that tells us the absolute value of x is 3, then what are my choices for 3? In other words, what kind of numbers can this x be? In other words, what kind of values are exactly 3 units away from 0? Well, if I go this way, I'm going to find the number 3. If I go on the left side of 0, I'm going to find the number negative 3. So I am going to get 2 possible answers for this x value. It's either 3 or it's negative 3. So let's solve absolute value equations that have maybe a little bit more than just absolute value of x. So just as the problem above says, we always have to translate what does that mean for the quantity inside the absolute value. So if the absolute value of this 2x minus 7 is 9, that means 2x minus 7 in this absolute value bars, I'm either going to have a 9 itself, or maybe this 2x minus 7 is a negative 9. So what I could have inside these bars to make it equal to a 9 is either a positive 9 or a negative 9. And that's how each absolute value equation is going to work. So I get 2 choices for the quantity inside. And from here out, we get to simply solve add the 7, divide by 2. Add the 7, divide by 2. 2 answers. Let's try this again. You can try yourself. So this quantity inside the absolute values is either 5, so I must have a 5 in here, or this x plus 2 could also be a negative 5, right? And then I'm still going to get the same answer. Okay. So here it is. Either x is 3 or x is minus the 2 over negative 7. Now sometimes it happens that our absolute value is not by itself. So we first must isolate the absolute value. So get the absolute value by itself. You cannot distribute in by the way, this negative 2, if you think about it. These are not parentheses. These are absolute value bars. So they do something to the quantity inside first. You cannot distribute the minus 2. But what I want to do is I want to get this absolute value by itself first. Okay, so therefore, I'm going to move the 3 over. Divide then by negative 2, because negative 2 is multiplied to this absolute value. So when I divide by negative 2, I'm going to get 1.5. So negative 3 divided by negative 2 is 1.5. And now I can translate my two separate equations. So then either x minus 1 is 1.5, which makes x a 2.5 when I add the 1 over, or x minus 1 is negative 1.5, which is going to make x equal to a negative 0.5 when I add the 1 over. Okay. So let's add 5. In other words, isolate the absolute value first before I get to translate what it means. And then now that the absolute value is by itself, my two choices for x minus 3.5 is that it's either 12.5 or the x minus 3.5 is negative 12.5. So you get the absolute value by itself, and then the quantity inside the absolute value is the plus or the minus number in here on the other side. And here are your two answers. And that's how it goes every time. Let's try this one more time. So I'm going to minus 6 over divide the 2 because it's multiplied on. And if you go mechanically and move on and find your two x's, you probably will get that one of them is negative 2 and the other one is positive 4, but it's not going to work because let's say you found 4. Is the absolute value of 4 minus 1 equal to negative 3? No, the absolute value of 3 is not negative 3, it's positive 3. And the same thing, if you have a negative 2 in there and you get a negative 3, the absolute value of negative 3 is also not going to equal to negative 3. So you have to be very careful with absolute values. That's why we don't get to just distribute things in, because the absolute value actually means something, and it does something to the quantity inside. And what it does, it's always making the quantity inside the absolute values a positive. Okay. So the absolute value always has to be a non-negative value. So it can never, ever equal to a negative. Whoops, I don't know why this keeps jumping. So this is never going to be possible. Therefore, this equation, don't even bother, has no solution. You can never get a negative across or to equal to an absolute value. Done. So here is one more. This one's going to work. Again, I suggest that you pause the video and try the problem yourself. So I'm going to minus the 2, divide by 5, and 15 divided by 5 is 3. And now you can tell me what that means. And it's a positive number, so that's fine. So 3x minus 1 could be 3, or 3x minus 1 could be negative 3. And then we get to solve both these equations easily for x. All right, so hopefully you did that yourself. Okay, solving an absolute value inequality. We do have two choices. Either we say the absolute value of x is less than, let's say, or equal to some number 3, which means what? Less than or equal to 3, that means I'm looking for all the x values that are less than 3 units away. Well, exactly 3 units away would be the numbers 3 and negative 3 as discussed before, right? So less than 3 units away would be this on the right side and this space here on the left side. So this is what it means to be within 3 units away from 0. So that translates into the fact that x's themselves have to be less than or equal to 3, but greater than or equal to negative 3. In other words, in between negative 3 and positive 3. So that's what it means to be within 3 units away from 0, right? Less than 3 units. 2.9 units, 2.8 units, 2 units, right? In both directions. When you look at an absolute value that is greater than or equal, and that makes the rest of the number line. So here is 0. Here is exactly 3 units away from 0. Exactly 3 units away, but more than 3 units away actually means these two parts of the number line, right? So the other pieces of the number line aside. So to the right of 3 and to the left of negative 3. So what that means for these x's is that either x is less than or equal to negative 3, or x is greater than or equal to 3. So it's to the right of 3 or to the left of negative 3. So what this means on the number line is anywhere from negative infinity up to negative 3, or 3 to infinity. And remember, the or symbol is the union symbol. Okay. All right, so let's solve some less than or equal and some greater than or equal inequalities and write our answer in interval notation. So to be less than 17 units away from 0 means to be in between negative 17 and positive 17. That's where you're, and you can draw yourself a picture if it helps. Within 17 units away from 0 means in between negative 17 and positive 17. And if you remember, we solved such what we call double inequalities back in section 2.1. And that's exactly why we solved them, because I knew we'd come across them later in the chapter. Okay. So remember, we want to write the interval and the answer in interval notation. And for that, we always start with the lesser possible value up to the largest possible value. And you can also very well change these numbers to a 5.5, and I believe this one's negative 11.5. So you can write it in decimals or you can write it in fractions. It doesn't matter. Okay. Here it is. Before we even translate our absolute value inequality, we must isolate the absolute value first. So I have to add the 7 over. All right, and now what does it mean to be less than 5 units away from 0? It means to be less than 5, but greater than negative 5. So in between negative 5 and 5. All right, and so again, solving this double inequality, for x, I'm going to minus the 3, and then divide by negative 4. And if you remember what we did is that we had to remember to switch the inequality symbols, right? When we divide by a negative number. And it's great because an inequality always has to point to the lesser number and open to the bigger number. So 2 is greater indeed than negative 1/2. So when we write this answer in interval notation, again, we start with the smallest possible value, which is negative 1/2, comma, largest possible value, which is 2. And again, reminding you of the notation, if it says or equal, we use the bracket. Here it doesn't say or equal, so we use a parentheses. For this last problem, again, be very mindful of the fact that you have a negative number across from your absolute value. So when is really any positive number, absolute value of something is always a positive or maybe even 0, that's fine. But when will a positive number be greater than negative 3? Never, right? So that's not possible. It doesn't matter what you're going to plug in here for x. The absolute value of that will be something positive, and no positive number is less than negative 3. All positive numbers are to the right of negative 3, so that's not possible. Right? And we're done. So be very mindful of negatives across from your absolute value. All right. And then here are a couple more that say greater than. So for these, I just made them, even though it says greater than, it doesn't matter. I just try to introduce more steps, as in isolate the absolute value first. So minus the 2, divide by 5. That's the first task. Get the absolute value by itself, whether it equals, it's less than, greater than. Okay, so the absolute value is greater than 1. What does that mean? That means that this 3x minus 1 is more than 1 unit away from 0. So it's more than 1, or on the lesser side of negative 1. So it's to the right of 1. Again, in this situation, more than so many units away. So to the right of whatever, 1, in this case 3, and to the left of negative 1. So that's what it means. So solving now these inequalities, add 1, divide by 3. Same thing, add 1, divide by 3. So what that means is that my answer is, let me see if I can squish it down below, between negative infinity and 0, so less than 0, or more than 2/3. So from 2/3 up to infinity. And put it on the number line if you need more help to see it. And here is last, well, not quite last one. But I have the absolute value of 2 minus 5x isolate the absolute value is greater than or equal to 12. That means what? 2 minus 5x is itself greater than or equal, more than 12 units away from 0, so more to the right of 12, or, I know I keep switching them over, it's because usually it's an x first, or to the left of negative 12. So either way, actually, if you look at both your inequalities, you have to switch the inequality sign and switch the sign. More than 3, less than or equal to negative 3. Less than 3, more than or equal to negative 3. So you switch the sign and the way the inequality symbol points. So I'm going to minus the 2, divide by negative 5, and because I'm dividing by a negative 5, I'm switching the inequality symbol. Minus the 2, divide by negative 5, so here you have it. Either x is less than negative 2, so negative infinity up to negative 2, or more than 14 over 5. So from 14 over 5 to infinity. Okay, and here's the last one, and again, what do you see? You have a negative across from an absolute value, okay? Think, though, this time, and it's very important to think. That's really what mathematics is all about, not mechanics. Yes, we do have steps, and we have mechanics of this is what you do, and so on and so on. Just efficient paths to get to the answer that have been fine-tuned over centuries, but it's always coming from thinking. So here I have the absolute value of something is greater than negative 2. So same thing, when is a positive number greater than negative 2? Well, always, right? All positive numbers are going to be greater than negative 2. So therefore, the solution here is all real numbers. Any number that's going to be plugged in here for x would make this a true statement. Okay, positive, negatives, it doesn't matter, because as soon as you plug it in and you take the absolute value, you'll get a positive, right? So again, no absolute value is less than a negative. No absolute value is equal to a negative. But all absolute values are greater than a negative number. All right, and here just again, what does an absolute value really sound like in real life? So it says describe all numbers x that are a distance of 4. So the absolute value is 4. The distance, remember, the absolute value of something is the distance. So the distance is 4, and these numbers x are a distance of 4 from 8. So if you think about it, here's the number 8. Which values are 4 units away from 8? Well, one of them would be 12. So yes, 12 minus 8. Absolute value of that is 4, and the other one is 4. 4 minus 8 is a negative 4. Absolute value of negative 4 is 4. So here it is. It's a correct statement. So start again with this. The distance is at least 15 units. So the distance means right absolute values. that a point is from 10. So the distance from 10, so the difference from that number to 10 is at least 15 units. At least means 15 or more. Okay. At least 15. So 15, 16, 17, right? At least means 15 or more. Okay. So the distance from a point to 10, so in other words, the difference from that number down to 10 or up to 10 has to be more than 15 units. So distances are described with absolute values.